This is our 66th lesson on this, and I know it seems long and drawn out, but we need to cover as much of this material as we can because we have the atheists attacking on areas where they think we can't answer them, and I'm trying to deal with that. Most of the arguments that I run into by atheists. And some old Earth creationists also argue very strongly that the flood was local, that it wasn't universal. We're going to look at recommendations continued from last week that we had recommendations for additional study. We'll make some more suggestions to see if the Fox flood model harmonized with more things that have been discovered by scientific research. And we'll try to open some avenues for other research and study. And some of this will just be research of the literature, and I'll discuss part of it as we go through. If the Fox flood model is sound, then it should harmonize with additional discoveries, and hopefully it will. We're going to introduce additional matters for study in this lesson, and we should look at the effects of reduction of the atmospheric pressure during the 40 days of rainfall. If the water vapor canopy raised the barometric pressure, we showed evidence in earlier lessons that occurred. Earlier lessons showing the barometric pressure was higher than it is now, as well as the oxygen content was higher. And if that's true, how would this affect other things? What effects would it have? There's a law of chemistry and physics called Henry's law, and it basically is used to discuss the lowering of atmospheric pressure. But there's three factors that come to bear in what we have with gases that are soluble into liquids. And we're just interested in the liquid known of as water. We're not interested in the gases soluble in gasoline and other stuff like that. So we're just interested in water because the oceans are mostly water. And of course, our blood is mostly water. Okay? Now, there's three factors that determine how much oxygen we can get into our blood, for example, or oxygen into water, or carbon dioxide into blood or water, either one. Now, these two gases are the two that are most important for us here. So if we increase the barometric pressure, the barometer, there's more gas will stay in the water because the barometric pressure will push down on it to keep it from coming out. What happens is, as the gas heats up, the molecules, and all the molecules, including the oxygen and the carbon dioxide molecules, will get more kinetic energy. That means they'll start moving more. And if they get enough kinetic energy, they get moving fast enough, they will penetrate the surface of the water and go out into the air. Now, if the barometric pressure is higher, they'll be pushed back down into the water or can't come out. And so there's three factors that are important here. Number one is the barometric pressure. Number two is the temperature. And then we can have how much oxygen is actually in the atmosphere and or carbon dioxide. So from Henry's law, the lowering of the atmospheric pressure, the barometric pressure, should have caused air, and this is O2. This is what we breathe, oxygen, O2, and CO2, which is carbon dioxide, we breathe out. The plants take that in. This would have come out of the oceans. The oceans then would have lost these gases. And I remember as a boy, some of the boys would take a Coke and they'd shake it real good, then they'd take the cap off it. When they did, it would spew all out. It would spew out, make a mess. And they'd kind of laugh about it. Well, what it was is the Coke, the soft drink manufacturers, they put carbonated or carbon dioxide under pressure, about a couple of atmospheres, about 2 times the atmospheric pressure, 1.5, 2 times, somewhere thereabouts. And they put it under pressure. And that puts a lot of carbon dioxide into that soft drink. And then whenever it's cold, if it's cold and you take the cap off, it won't spew out. Because the colder it is, the more of this gas it can retain. Now, we went through this earlier, and we said this is why the fishing up around Alaska is so good and around Labrador Grand Banks. The water's cold, and so there's more oxygen in the water for the fish to breathe. So fish get larger, and they're able to be healthier. In the summertime in Oklahoma, for example, we'll get hot weather, and if it gets hot for a week or two, what'll happen is the farm ponds and little lakes will get warm enough that the oxygen will come out of the lake. And what'll happen then is fish start dying. And they talk about the fish kill. Well, it's just probably oxygen coming out of the water because the water is too hot. That's all it is. And of course, this change in barometric pressure would affect the oxygen and carbon dioxide that's in the water. But both oxygen and carbon dioxide would come out of the water. Now, we can see this now. The change in temperature would also affect it as well. If the temperature got hotter, it would come out of it more. If it got colder, it would retain it more because it would slow the molecules down. They can't exit the material to the surface. Now here's Henry's law illustrated. With a certain amount of pressure, we have a certain number of molecules, and the black ones and the red ones. And what happens is when we compress it and increase the pressure, these red molecules that are up here will go down into the gas down below because of the increased pressure. And that's just a simple illustration of this right here, just with a piston or compression to pressurize it. Questions? Any questions here about that? Right. This is similar to the air that exits a soft drink when carbonated water and when the cap is removed, particularly if the bottle is warm. If it's real warm, it'll really come out. And if it's cold, it won't. If you got it real cold, it won't come out. That's probably why they want to keep them cold when they open the bottles, because it'll spew out otherwise. Right? When the pressure is lowered, say, carbonated water will come out. There might be some sort of evidence from the sedimentary rocks, such as air bubbles in the rocks, for this reduction in pressure. Now, what I'm claiming is that when the 40 days of rain occurred, it decreased the barometric pressure over that period of time, and this water then came out of the ocean. Not water, the gases, and particularly oxygen, carbon dioxide, and some other gases too came out. Anything that's soluble, gases that are soluble, would have come out. Reduction of atmospheric pressure would cause calcium carbonate. We'll give several sources for this. To precipitate out of the water and to be deposited in layers in the sedimentary rocks. Now, one of the things the atheists do is they say, well, look at all this calcium carbonate. These are rocks that have calcium carbonate in them, dolomite and stuff like this. And we'll give some rocks here, types of rocks that have this in them. But these rocks then supposedly took billions or hundreds of millions of years to deposit because they make uniformitarian assumptions about this. But if this 40 days of rain lowered the barometric pressures drastically, then it would have precipitated this out, could precipitate it out in just 30 or 40 days. Longwell and others, et al., state that a loss of carbon dioxide will cause calcium carbonate to precipitate from the water. Well, that's pretty easy to do in the chemistry lab. They can set it up and see if it happens, and of course it does. It'll precipitate out. Calcium carbonate will. Now, here's a source that they are explaining how varves occurred. Now, we've talked about varves the last lesson or two, layers of of rock that was sediment that was settled and formed into rock in the bottom of a lake, usually. In each bar of one lamina, or layer, consists of calcium carbonate. The other includes dark-colored organic matter. So now we have organic matter, and then we have calcium carbonate. The rhythm is explained as follows. Why is there a rhythm of these two? Well, calcium carbonate weighs more. It has a greater mass. So it'll sink to the bottom quicker, and the dead organic matter then will settle on top of it. So that's what he's explaining. Now, let me read on, and we'll see how he explains it. The rhythm is explained as follows. The sediments were deposited in a lake, which warmed in summer, therefore lost carbon dioxide and precipitated calcium carbonate from solution. So once it loses the carbon dioxide because it warmed up, remember, there are three factors that determine how much oxygen, O2, and carbon dioxide is in the water. And that's the temperature of the water, the barometric pressure, and how much carbon dioxide and oxygen is in the atmosphere. And so what we have here is when this occurred, they're explaining it here that we lost carbon dioxide and that caused the precipitation of calcium carbonate from the solution. The relatively heavy carbonate sank promptly and formed a summer lamina when it got warm, just like I was talking about the fish dying. The lighter organic matter sank much more slowly. And of course, these animals, these organisms died because of the loss of oxygen or carbon dioxide. Now, the loss of carbon dioxide would kill the plants, loss of oxygen would kill the animals. Calcium carbonate is found in several forms in the sedimentary rocks. Limestones, one of the things where it's found, contain calcium carbonate, secreted by organisms. Now watch what Longwell says, are precipitated from supersaturated waters. Now, my claim is that the waters before the flood would have been supersaturated because of the nature of the barometric pressure and the nature of the fertility of the soil and the fact that the ocean and the waters and the land would have had optimum values of minerals and everything it needed to grow things. So limestone. So we got two sources of the calcium carbonate: organisms or supersaturated waters. Now, to get back to what we've had here, it would drop out. The inorganic calcium carbonate would drop out because it's more dense. It was heavier. We might think of it that way. It's heavier, settles quicker to the bottom. Some atheists claim that the depths of the limestone prove that the Earth's billions of years old because they claim it was all secreted by organisms. And of course, Longwell says, or precipitated by supersaturated waters. He gives another option for it. If the organic matter were lighter than the calcium carbonate, this explains the layers. And we do see layers. A Fox flood model would have supersaturated water precipitate calcium carbonate during the flood as the barometric pressure dropped. So that's what we would see there. Other sedimentary rocks, which are derived from calcium carbonate, include dolomite, or wollastonite, and diopside, and some others as well. But these are different variations of formed from calcium carbonate. Sumner and Grotzinger relate the precipitation of calcium carbonate with oxygen concentration. So if we lose oxygen, it will precipitate out. That's precisely what we're saying happened. And that's precisely what would have happened if the flood, the 40 days of rainfall, changed the barometric pressure from maybe 3.5 times the atmospheric pressure we have now to what it is now. And that lowering barometric pressure would precipitate out all of these calcium carbonate was to form these rocks. Different amounts at different times would give you the different kinds of rocks. Phosphate and other chemicals would precipitate out of the floodwaters as the barometric pressure changed. I haven't gotten into the chemistry of that to try to figure out what other things we might look for. But this would be something that someone with a good chemistry background could see what else might be precipitated and what else we might find as further evidence. And I probably am not going to live long enough. I'll be 80 years old next year, and I doubt that I'll live long enough to do all this research. So hopefully someone else will pick up the gauntlet and carry it forward. The partial pressure of a gas, and that's what we're talking about here, how much it can have in the gas, in the liquid, is determined by the gas itself, the temperature, and the barometric pressure. These three factors that we've already talked about. Crumbine and Sloss state, here's another one that gets this calcium carbonate. Calcium carbonate may be precipitated from seawater by inorganic processes. So it doesn't have to be organic. Changes in atmospheric partial pressures of carbon dioxide produce corresponding changes in calcium carbon dioxide solubility. So again, that changes the solubility of the carbon dioxide, the partial pressures. Because of these relations, there's a direct connection between atmospheric carbon dioxide and the amount of dissolved carbon ion in seawater. If the carbon dioxide, he continues, dissolved in seawater decreases, some bicarbonate ions change to carbonate, thereby causing precipitation of calcium carbonate. The precipitate forms a fine crystalline cloud which settles to the bottom. Observations show that surface water is in some warmer parts of the ocean is saturated with calcium carbonate. Because the warmer it gets, the more it can come out of it. So the temperature is a factor, see. This suggests that at present, the warmer seas are potentially large limestone accumulators. What he's saying is this can come out and it's not organic. It's just from the change in barometric pressure or change in temperature. That's exactly what my flood model says. That similar conditions may have existed in the past as attested by numerous limestones. Listen to this, having relatively dense crystalline texture and a plasticity of fossils. Now, plasticity means it doesn't have very many. They're rare. So not many fossils in it. So that's pretty interesting. That exactly fits the Fox flood model. So some other effects. Still another factor that needs to be considered is the fact that the changes in the barometric pressure during the first 40 days of flood, when the water vapor canopy was being dissipated by the 40 days of rain, would have killed massive numbers of organisms. See, fish kill occur in the lakes in Oklahoma in the southern United States when it gets hot during the summer. This would result in a rapid deposition of organic calcium carbonate during that time. So we can see layers of organic calcium carbonate as well as inorganic. The atheists, the agnostics, and the old earth creationists have made uniformitarian assumptions about the deposition of calcium carbonate. They assume it's occurred steadily over a constant rate over millions of years. And they've gone back to their uniformitarianism. And the whole system is based on uniformitarian assumptions. Now, let's go to another matter. We've dealt with that sufficiently, and as we might say, Cloud and others claimed the length of the day was shorter in the past. Well, if the flood was caused by interaction with the planet Mercury, which I believe it was, then there would have been transfer and exchange of angular momentum, and it would have changed the rotational speed of the Earth, would have slowed it down. And they say another feature of the interval of Earth history was probably a much shorter day than now. So the length of the rotational speed is slowed down, so the day got longer. The days got longer. So there's evidence that the days were shorter in the past. I would say probably the days before the flood were maybe 23 and a half hours or something like that long. And we're going to look at that in some more detail. Now, of course, the atheists in claiming the Earth is billions of years old, and the moon's been circling the Earth for billions of years, a billion or more years, then they have a problem because it should have been real close to the Earth. And we dealt with that last week in our last lesson. The problems that they have with that, because it would have been closer, and it's moving away from the Earth right now, and it has been. Additional research should be conducted on the effects of a shorter day upon living organisms in the antediluvian environment. How would this affect organisms? Possible that the biological clocks, circadian rhythms of some organisms are better tuned to this shorter day than to the present 24-hour day. That's a possibility. Now, our problem that we run into with this is we get organisms such as plants and animals that function based upon the amount of sunlight. And some animals and some plants function with different levels of sunlight. And so it's a problem, and I've tried to do research on it, and the problem was that I found that there are plants that needs 5 or 6 hours sunlight, some that need 8 or 10. And again, what we run into is there's just so much variability there. Probably God created them to handle the different parts of the earth and to survive in different parts of the earth. Some places where they don't get as much sunlight, some where they get more. Let's look at the cratering of the moon, for example, and we know there are craters there. And the atheist claims at one time there were no craters or very little craters. I would argue that the cratering was largely done by the rings of the planet that caused the flood. And it probably changed the albedo of the moon and reduced it. Now, what's albedo? We've talked about this twice already on 2 different occasions. It's the reflectivity. An albedo of 1 means that the object is a total reflector. It's like a mirror. It reflects all of the light that hits it. It just bounces off. And albedo 0 means it doesn't reflect anything. The light won't reflect back. So it won't even be seen because it will not reflect any light or emit any light. And so it's almost like a black hole. And so the albedo would change due to these irregularities in the shape of the moon, due to the craters. It would lower it. That is, the moon would reflect less light and it would not be as bright as it is now. That is, it would not be as bright as it was before the flood. So it would be dimmer now than it was then. A reduced albedo for the moon would decrease the amount of moonlight reaching the earth. How would this affect such things as plants and animals? That's the question. In addition, the absence of clouds in the antediluvian atmosphere, that is, there were no clouds before the flood, would also mean that the moonlight was brighter before the flood than it is now. So there's 2 factors that would make the moonlight brighter. So the nights would have not been nearly as dark as they are now. And of course, what we're going into then is, of course, the moon would move around the earth, but there would be times when it would be dark, but it would reflect much better when there was a moon. I don't know what happened here. Can you guys still see my slide?
Yes.
Okay.
Yes.
We need to look at how plants and animals reacted to this. I don't know what happened. Something happened. I lost my slide. Okay. Patton, in the book that Ice Epic, Biblical Flood and Ice Epic by Patton, it's a good book. I got some ideas from him, but he discusses ice caves in the Frenchman Hills of Grand County, Washington, pages 120 to 124. And these ice caves are another phenomenon that the uniformitarians had difficulty explaining. Now, this may be a dead end on us right here. These caves appear to have alternating layers of lava and ice. When I tried to research the caves and get information from people that were in charge of them, they wouldn't talk to me about it because they said they didn't want people coming into the caves and damaging them. And so I tried this several years ago, and I told them, and I was a college professor, and I just wanted to get information to talk about it. And they said, well, we're not going to help you any, sorry. So I tried two sources, and they both gave me the same deal. So I can't get information, and they wouldn't even tell me where they're located because they're afraid people would get into them and damage them. Well, that's probably true. There's some people out there would do that, and I can see why they would. But anyhow, I wasn't able to follow this up. I tried to, but I wasn't able. And it appears that from what I can get from this, is that we have layers of lava and then ice and then more lava on top of it. Now, if that's true, then this ice must have been extremely cold, or there might have been just tunnels through the lava where the lava tunneled through, and then it filled with water and cold weather it froze. That's a possibility. But if it's layers, then it had to be extremely cold ice to suck the heat out of that lava. And it had to be extremely cold to do that. The way it's described, that's what it seems to be the case. That I can't verify because I couldn't get information from the sources that are in control of these caves. They're discussed by King and Jiang, and they're in other parts of the northwestern United States as well, Idaho and Washington and in that area up there. Additional research should be conducted to determine if these caves are a result of lava flowing out over extremely cold ice. That's just near absolute zero without melting. And Lisinski and Sisson talk about this. There's some other sources. Now, let's look at another question. The ice caves is another question that I just couldn't get more information on it. If Mercury approached the Earth above the ecliptic plane and the moon orbited the Earth in the ecliptic plane, now we've already shown this earlier, and before the flood, then Mercury probably pulled the orbit of the moon out of the ecliptic plane. Now, what's the ecliptic plane? If you draw a line from the center of the sun to the center of the Earth, that's the ecliptic plane. If the center of the moon was also on this line, then it was lined up with the Earth, the ecliptic plane. Now, this would have made every day there would be on the Earth, there would be a shadow cast, and we would have eclipse of the moon every day. We'd have every day, the moon would put a shadow on the Earth. And it would probably be pretty much the same location. They could see it. And so it would pull it, if it came in, Mercury came in, it would could pull the moon out of the ecliptic plane and change the orbit of the moon as well. This could have provided a mechanism for the deposition of ice on the poles of the moon. Now they have discovered, I predicted this with my book more than 20 years ago, that they would find ice in the poles of the moon and craters, and they have found it. And it's particularly at the North Pole, we see it. We see it at the South Pole as well. If Mercury approached above the ecliptic plane, the moon orbited first in the ecliptic plane, the North Pole of the moon would be cratered from the first pass over the moon. But the North Pole should not have extensive cratering, or at least it should have minimal cratering at the North Pole. Right? If the moon revolved around the Earth in the ecliptic plane before the flood, the regular lunar eclipses might have been used to measure the seasons. This may be the explanation of Genesis 1, verses 14 through 16. And God said that there be lights in the firmament of heaven to divide the day and from the night, that there be for signs and for seasons, for days and years, that there be for lights in the firmament of heaven to give light upon the earth, and it was so. God made the two great lights, the greater light to rule the day and the lesser light to rule the night. He made the stars also. We assume the greater light is the sun and the lesser light is the moon. It's a light of reflection. So here, the moon would have been much brighter. And also, if it were in the ecliptic plane before the flood, it could have had a regular eclipse. And the eclipses would have been regular. They could measure time back by the eclipses. That would be a thing that they could do. So research needs to be conducted. And here's something different. The core of the Earth travels at a different angular velocity, rotational speed, than the remainder of the Earth. Did you know that? That is interesting. Kerr states, and all these are in my book, a team of seismologists announced last week that Earth's solid iron inner core spins faster than the rest of the planet, gaining almost a tenth of a turn during the past 3 decades. What it gains about 1.2 degrees, if you read all the articles, every year, 1.2 degrees in angle rotation. Song and Richard claims the rotation rate is order of 1 degree per year. And when you look at it more carefully, it's 1.2, about 1.2, faster than the daily rotation of the mantle and the crust. So the core is rotating faster than the rest of the Earth. How can that be? That's the question. Right here, you see the core is rotating at a faster rate than the rest of the mantle and the crust of the Earth. Now, this mantle and this outer core is supposed, we call it liquid, but you know, it's still liquid in that it's not solid, but it's like this. If you take a jar of honey and turn it up, it won't run out of the jar as quickly as water would run out of the same jar, because the honey is thicker, but it's still liquid. And so the mantle and the liquid outer core are still liquid, but they don't move. They're pretty sluggish in their movement. They do move. So what we have here is this inner core rotates, solid inner core rotates faster than the rest of the Earth. And it lines up, it's tilted on its axis. It doesn't line up with the axis, the north and south pole of the rest of the Earth. So it rotates and it's twisted on the axis here. You can see how they show it's twisted. And this creates, as it rotates around, creates this rotation up here. And that is amazing. But that'll fit my flood model. Here are the sources. And there are other sources now that you can cite and go to see where you can get more information about this. This has been widely accepted by the scientific community. But this claim raises serious questions. Number one, what mechanism would cause the inner core to rotate faster than the remainder of the Earth? How could that happen? Second, how long would the friction between the inner core and the remainder of the Earth allow a difference between the angular velocity, which is rotational speed in cycles per second or cycles per year or whatever, velocity of the inner core and the angular velocity of the remainder of the Earth? How long would that occur? How long would it continue to occur with friction? How does this relate to the tidal influence of Mercury on the Earth during the 150 days of the tidal activity, possibly decrease the rotational speed of the Earth? Did it decrease the rotational speed of the core, or did it reduce at a different rate than it did the rest of the mantle and the crust, which are somewhat liquid? So, to me, what happened? How does this relate to the reversals of the Earth's magnetic field, either real or imagined reversals? Now remember, with a magnetic field, if it's nonlinear, anything's nonlinear, it generates harmonics. Did a Fourier analysis, and so that would give us the imagined reversals, looking like they reversed. It's possible that the Earth's magnetic field is aligned with and related to the core of the Earth, that the core is aligned where it was, or approximately where it was prior to the flood in the antediluvian world environment. That the alignment of the remainder of the Earth, the crust and so forth, mantle, was tilted. Is this why the Earth's magnetic pole wanders? That's a good question. Now notice the magnetic pole, the North Pole of the Earth, geographic pole, is not in the same location as the magnetic pole. They're offset a bit. That's called declination when you do navigation. When you navigate, you have to do what's called declination. Now, Oklahoma City, where I live, is just about right. In other words, our compass is pointing almost straight north. We're off about a degree. You get out in California or places like that, or way up in Alaska, you're off 30 or 40 degrees with your compass. You have to correct for it. Now then, what we have at the North geographic pole is the South magnetic, but that's another matter in itself. And so that's what we have there. But the South geographic and the magnetic pole at the South is not lined up. They're not lined up with the North Pole either. Now here, the North Pole has been wandering around. Is the pole linked with the solid core, inner core of the Earth? If it is, and it rotates at a different angle than the rest of the Earth, then that would explain why it wanders or wobbles around. The present rotation of the core at a rate of about 1.2 degrees per year, faster than the remainder of the Earth, is many orders of magnitude greater than the supposed reversal rate of the magnetic field. So you can't link them together with the same time frame that they give for the magnetic field. Of course, I think their dating of this magnetic field reversal is wrong. This means that the core gains one revolution on the mantle and crust about every 300 years. So every 300 years, it's going to rotate and start all over again. It's possible the Earth's magnetic field is lined with and related to the core of the Earth. The core is aligned where it was prior to the flood, and that the alignment of the remainder of the Earth was tilted, or that both were tilted, but tilted in different amounts. And is this why the magnetic pole wanders? That's the question I ask. Does the core of the planet Mercury, this is another question, also rotate at different speeds than the remainder of the planet? Now, they haven't devised a way to measure that yet. If they do, I predict that it will wander as well, that it will also rotate, that it won't be lined up with the crust and the mantle. That's my prediction. Rise it, the lesson will be yours. Many additional matters need to be researched to determine if they're in harmony with the Fox flood model. Remember, a good hypothesis will predict future matters and lead to new discoveries. This is our lesson.